Hear that? Believe it or not, summer is just around the corner. Luckily, Armor All, America's most trusted auto appearance brand, has what your car needs to get that perfect summer shine. Plus, now through May 31st, we'll give you $5 for every $20 you spend on Armor All products. That means car wash pods, protectant, tire shine, you name it. Find out how to get your $5 rebate at armorall.com. Armor All, less work, more clean. Terms apply.
BoShield wasn't satisfied with any of the bike lubes on the market, so they engineered their own. Their research proved that none of the Teflon, silicone, or synthetic formulas held up when exposed to dusty, dirty, and muddy conditions. For that reason, BoShield T9 is designed to offer long-term lubrication and protection in any environment. BoShield T9 waterproofs your bike chain, lubricates cables, and prevents rust with its effective all-in-one formula. The paraffin-based lube flushes out dirt and old lubricants, displaces moisture, and penetrates moving parts. Then it dries to a clean, continuous wax film that performs better than Teflon and lasts up to 200 miles. BoShield T9 is designed to resist picking up dust, dirt, or mud, which makes it a good choice for all riding conditions. This month, BoShield is giving away a free prize pack to a lucky listener. Go to singletracks.com/BoShield to enter and visit BoShield.com to learn more, or click the links in the show notes. Hey everybody, welcome to the Single Tracks podcast. My name is Jeff, and today my guest is Dr. Chris Leatt. So Dr. Leatt is the founder of the eponymous bike and moto protection brand based in South Africa. The company's bike product line has expanded over the years to include helmets, pads, goggles, and even hydration packs, all designed with a focus on safety and protection. Thanks for joining us, Chris.
Thanks for the time, Jeff.
So tell us how your company got its start.
So it's around 17 years ago now, where the concept of a neck brace, which is the product that started the company, first came to mind. I was at a sporting event, and in this instance, it was an enduro motorcycle event. I was post-call. I was a resident in neurosurgery and quite tired from a very long week. So I wasn't competing, but I went to watch an event with my 4-year-old son, who'd ridden a motorcycle for the first time 2 weeks before, a little Yamaha PV50. Mm-hmm. And with great delight, he'd taken off down the road and fallen off into the nearest bush, and seemed absolutely enamored by the concept of a motorcycle. And so we went together to watch an enduro event, and unfortunately, sitting having a chat to one of the paramedics who I knew from who delivered patients to us at the teaching hospital I worked at, said to me, he just got a call. Can I come with him to see a patient that is in a critical condition on top of the mountain? We went up in a 4x4, Matthew, my son, with me. And unfortunately, a rider by the name of Alan Selby, whom I knew, had fallen over the handlebars in a downhill section at relatively low speed, and we suspected he had broken his neck. Unfortunately, I tried to resuscitate him, and we had all the right equipment, but unfortunately, he couldn't be resuscitated, and I suspected he'd broken his neck. Mm-hmm. And later on, I received information which confirmed the fact that he'd broken his neck from an autopsy. Had to tell his wife and family at the time of the event, and it was obviously very traumatic. And as at that point in time, I said to my son, well, you're not going to ride a motorcycle until I find a neck protection device in the market that works. And I thought it would be a simple exercise of just looking hard enough to find one. Of course, there wasn't one. And it was many years of work then that took me to the point where I'd researched the major injury vectors and the mechanisms of causation of neck injuries in off-road motorcycling, which applies in many ways to the bicycle sports as well, and understood what needed to be done to limit neck injuries. So the company started on the back of the neck brace, and the way the neck brace works is what we call an alternative load path technology. So if you have a platform underneath your helmet that can be loaded, if you fall off a bicycle or a motorcycle and land in your head, say going over the front of your handlebars, without a neck brace in place, the force is transferred from the ground to your helmet, to your skull base, to your neck, and to the rest of your torso. And it's actually loaded in the upside down fashion. So it's the weight of your torso and the energy of your torso that's loading the neck. Mm-hmm. If you have a neck brace in position, the helmet rotates at some point and touches the neck brace. And some of the force, not all of the force, let's say 20%, some of the force goes via the brace to the rest of the body and bypasses the neck. And if you see the threshold for neck injuries as a high jump, you just never get to the point where the jumper can get over the jump. In other words, if the threshold, for example, of 5,000 newtons is required, or 500 kilograms of loading to produce a neck injury, with the neck brace on, the typical accident scenario doesn't produce enough force to produce an injury. So in a very convoluted way, we created an alternative load path to remove some of the energy from the neck and thereby reduce the incidence of neck injury. And that thesis has really been carried across to many of other products that we've developed thereafter, is energy mitigation and alternative load paths.
Yeah. Well, that's surprising that there wasn't anything on the market at the time. And I mean, I guess, so football here in the U.S. comes to mind, and football players obviously don't wear neck braces, but I guess it's the pads, like shoulder pads, interfacing with a helmet that kind of produces the same effect.
I'm not sure it's the same effect. And of course, the mechanism of injury in football is not always the same as motorcycling. So a lot of the injuries in football are spear tackling, when a player is running head down directly into another player. Mm-hmm. And there are other mitigation strategies that can be employed there, because in essence, it's almost a pure axial loading injury. So in other words, you fall off a motorcycle or a bicycle, you tend to hit your head, and then your head either flexes or extends. Whereas in American football, you are running sort of in a spear fashion, head down, straight into the other player.
Right.
Theoretically, a number of other advantages to wearing a neck brace that may apply to football, and that is that we believe that brain injury is less likely to occur with a neck brace in place than without one. At first thought, doesn't really make sense, but if you think about how head is impacted in an accident, say you fall off a motorcycle and land in your head. Mm-hmm. Initially, your head comes to rest on the ground, and then your head accelerates relative to your torso. So if you watch high-speed video footage of motorcycling events, and the one that we studied quite a lot is James Marshall, the extent to which his head moved backwards after the initial impact is extreme. So here you have a potentially brain-injured head that now is starting to accelerate again. And by catching the head earlier in that acceleration path with a neck brace, you actually can reduce the second impact sequence on the head. And we believe that over time we'll be able to show clinically that there's a reduction in traumatic brain injury. Of course, helmets are the right thing to use in terms of the primary insult, but secondarily, we believe that the neck brace is good for the brain.
Yeah, interesting. Well, how have neck braces for biking specifically changed over time? Today everybody pretty much calls a neck brace a Leatt. So obviously, your company was an early mover in the space, but have things changed much over the last several years?
I do think that the neck brace has evolved. I mean, if you look at the earliest models, they were quite heavy, cumbersome, without much adjustability, and not necessarily as comfortable as they are today. Mm-hmm. In terms of how they work, being an alternative load path, specifically in terms of the Leatt, the protective features of the brace are the same. It just is more ergonomically styled, more comfortable, and can be set up more specifically for a rider. When we started with mountain bike, we noticed that the mountain bike riders required a slightly different profile on the top rear platform to those in terms of motorcycling or motocross riders were, particularly when they were going downhill and having to look up. They needed a slightly different shape. Yeah. And so that has now been borne out in the new modern style neck braces that, they're now sort of ergonomically styled for downhill, which is the most aggressive type of mountain biking and where you're most likely to see a neck brace being used.
Well, the Enduro World Series recently shared a study of mountain bike injuries, and I imagine there are other sources of this data on injuries as well. What are the most common types of injuries associated with mountain biking? The neck injury clearly is the most traumatic of the injuries, but are neck injuries that common? What is sort of the common way that people are injured?
So, data collection and good quality data where you're comparing the same data fields and sources is something that we're always asking for, we strive to get, and we have a knowledge library within Leatt where anybody who's had a significant accident with or without an injury, with a neck brace in place, we compare the data. So the EWS injury statistics or data is fantastic, but I think, in time to come, hopefully we get better data. And by the nature of the game, it's best that this data is actually derived by people outside of a company manufacturing the safety apparel,
right?
Because it gives you good, honest data that everybody can apply across and for evaluation of numerous safety techniques, whether they're track design or safety apparel design. In terms of the most common injuries, they normally are limb injuries. So upper limb and shoulder, hand are the most common injuries. Collarbones, fractured hands, upper limb injuries, low limb injuries, and torso injuries. So because the numbers that are collected in these data sets of often quite small events, you see this statistically unreliable data in terms of the less commonly occurring injuries, whether they're brain or neck injuries. So if the data set is large enough, we can gain some really good insights. There was a Great Lakes EMS action sport data for almost 10 years in motocross in the US. Almost 10 years and almost 10,000 riders. And there the numbers were large enough to see that neck injury reduction was in the magnitude of about 89% less likely to injure your neck if you had a neck brace on.
Wow.
Which obviously is a really significant number. But I don't believe in mountain biking we have the right data to actually draw those conclusions. Having said that, the mechanism of injury is the same. So I think it's fairly safe to draw these parallels if the other injury types are also occurring. In other words, the magnitudes of the falls are similar in terms of producing brain injuries, upper limb injuries, torso injuries, to extrapolate the numbers for neck injuries and thereby apply the same prevention numbers that we see in motorcycling to bicycle riding, but at this stage, unfortunately, the data sets aren't large enough.
Interesting. Well, obviously, your company started out designing neck braces, but today you do a lot of other protective equipment as well, including helmets. How has helmet design changed over the past few years, and how does it work in terms of optimizing a helmet to prevent those neck injuries as well?
So I think, helmets are a relatively hot topic at the moment in terms of new standards that have been developed. So for a long time, standards remained very stagnant, and manufacturers used to design helmets to meet or exceed certain standards. Most of those standards were looking at what we call linear deceleration, so without a rotational component. We now understand that you need far less rotational energy to produce a devastating brain injury than linear acceleration. Mm-hmm. And therefore there's a move coming in terms of ECE standards in motorcycling, the new FIM proposed standard, where they're looking specifically at a rotational component and that helmets actually have to mitigate against rotational acceleration. So that's probably the single biggest protective change that is going to happen to the industry and is happening at the moment, is that standards now need to look at rotation. Obviously, styling is something that happens and changes over time, and it's what riders, the look that riders like. But in terms of the actual protection, I think the numbers are going to get bigger, and the rotational acceleration mitigation is going to be a much more significant component.
Yeah. Well, yeah. And we're seeing new materials as well. A lot of carbon fiber being used in helmets. Is a lot of riders, when they're wearing a helmet, they'll say a heavier helmet is uncomfortable, right? They get some neck pain from that. Is that a factor at all? I mean, obviously you're the expert on neck injuries and things. Is a heavier helmet, is it possible that that's harming people by wearing a heavy helmet? And should we be moving more toward lighter weight helmets?
Well, I think light is better on a number of reasons. Obviously, from a performance perspective, lighter is better. From a fatigue perspective, lighter is better. From neck injury perspective, there were some early studies that showed that heavier helmets over 1.5 kilograms can statistically increase the significance of neck injuries. Now, if you're looking at a bicycle helmet, you're unlikely to get to that number.
Okay.
But when we start looking at rotational acceleration, and those numbers were quoted in terms of linear deceleration, to the best of my knowledge. But if you start looking at rotational acceleration, which is being studied now, the heavier the head and helmet complex is, the more devastating it can be potentially for rotation. So I think on numerous counts, the lighter the helmet, the better. Having said that, of course, that's provided that the protective capacity of the helmet remains the same. And I think that's, the advent of new materials has allowed for, there's some quite clever ways of producing the previous standard EPS layer. There are anti-rotation mechanisms that are pretty lightweight in terms of the inner liner, the MIP system, our turbine system, obviously the outer shell, and a method of construction. The amount of glue and resin can be reduced to a minimum in terms of construction techniques, where you still have the same protective capacity, are all advances that, in terms of protection and performance, we're seeing in the industry today. It's quite an exciting place at the moment.
Yeah, well, the rotational technology that I guess a lot of consumers are familiar with is MIPS. And you mentioned Leatt's solution, which is called 360 turbine, I believe. How is that sort of different or similar to MIPS? And could you explain to us a little bit about how it works and sort of what the theory is behind that?
So what we set out to do with the turbine is to produce our own anti-rotation technology. And what we generally do when we're looking at a problem, and I mean, obviously rotation is a problem within head injuries, is to not look at what the rest of the industry is doing, but to rather make up our own mind as to how we would approach this. So, and we've used this way of thinking in designing a lot of our products. If it's from a knee brace to a goggle to a helmet, it's just to look at what we believe is the right solution to the problem. So we've developed a turbine which under load is distorted. It goes between the head and the EPS liner, nestled within the comfort liner, and it can distort as the head is rotated to mitigate against rotational acceleration of the head relative to the helmet. But what we found is, with using specific design and specific materials, is that we could actually reduce the low speed impacts, which are probably more commonplace, less devastating, but more commonplace. So you're more likely to bump your head not as hard as to end up with a traumatic brain injury, but more often in the pursuit of your sport. So what we looked at is relatively low energy mitigation in terms of the turbine as well as rotation. The reason we did that is because in order to pass helmet standards, the helmet actually has to be quite robust and rigid. So helmets, generally speaking, work quite well for a fairly narrow range of impact velocities. And by creating the turbine, what we did is essentially just increase that range of impact velocities.
Yeah, well, we've also been hearing too about these brain injuries that even vibration, like a lot of vibration over time, can lead to problems for people. Is there any way to mitigate that? I mean, other than just, having a different riding style, perhaps, making sure suspension is tuned. I mean, mountain bikers, especially if you're riding a lot of rough terrain and you're riding it at speed, it seems like over time that vibration is going to add up and could lead to problems. Is that something you've looked at or considered?
I think one of the best ways to mitigate against that problem is to wear a gum guard, and it has a number of benefits. So it's been studied for some time now that if you can stabilize the jaw joint, what we call the temporomandibular joint, if you can stabilize that, and for example, if you struck on the chin by in a boxing match, for example, if you're wearing a gum guard, that strike is less devastating, and less force is transferred into the brain if you're wearing a gum guard. In the same instance, if you are clenching your jaw onto a soft medium and stabilizing your temporomandibular joint, there seems to be some reduction in transfer of energy to the brain, but also you get a proprioceptive benefit. So your balance actually improves. So that's a study. I'm not aware that it's been studied in Rocky Downhill in particular, but that's a mitigation strategy that potentially could bear fruit and may actually be beneficial to some riders, and be interesting to know once they've got used to wearing a gum guard, how they feel about their balance and proprioception.
Yeah, that's fascinating. Yeah, that's definitely not something we've seen in mountain biking, but like all competitive sports, I'm sure any kind of edge that people can get, and it sounds like that's both safety and potentially, there's a benefit for performance as well. Are you seeing more mountain bikers choosing full face helmets than they used to? It seems like these days people are being more safety conscious and are seeing some of these studies and things that are out there. So has that translated into sort of a shift in sales for Leatt?
I must be honest, I'm not necessarily the right person to answer that question in terms of sales. However, we have seen a move to detachable chin guard helmets, where a rider, you cycling up a hill, for example, wants the freedom and airflow, but once going downhill wants more protection. But I think, as you've said, across the board, is people are becoming more protection orientated, because at the end of the day, you want to participate in your sport for as long as possible. If you have an injury, you're out of your sport.
Right. And
therefore, it makes sense to sponsors and riders to keep their athletes as safe as possible for as long as possible. When it comes to the weekend warrior, I have an idea that spouses may play a role as well, or mothers, children. Go ride, but wear this, please. So I think people are becoming more safety conscious, and the development of removable chin guards for helmets, I think, illustrates that people want the airflow up a hill, and they want the protection down a hill.
Yeah. And even your own sort of experience in starting the company, as a parent, watching a child get into a sport and saying, I'd be a little more comfortable if there were more safety options out there. And it feels like we're definitely seeing that, as mountain biking becomes more of a lifelong sport for a lot of people. What is something that mountain bikers might not know about helmets, but maybe that they should, in terms of what type of helmet they should purchase, or when they should wear them, or how they should wear them? Is there anything out there that would be helpful for mountain bikers to know?
I think it's all about doing your research when you get into sport. I mean, if you're going to go and ride sand versus rock on a regular basis, you're probably going to choose a different tire. You're probably going to choose different suspension setup. You're going to probably run different tire pressures, and I think there you've got to buy the protection that is relative to the sport in which you are riding. So I think choosing the right product for the right application is important. But just on a side note, I mean, things like replacing helmets if you've had a significant impact, if there's a mark on the helmet, and most certainly if there's any damage to the inside of a helmet or the EPS layer, sometimes, of course, it's very difficult to see that. You may only see a crease or a faint discoloration on the outside. If a helmet has had an impact, just get rid of it and buy another helmet. That helmet is probably not going to function the same in a second instant. I have seen a number of articles written on how many times helmets come loose during motorcycle accidents. I haven't seen that sort of data for bicycle accidents. But if you just have a look at when you're next riding with a bunch of people on the mountain, how many people's helmet chin straps are actually done up correctly,
right?
Where you can just slip two fingers underneath your jaw side by side, not one on top of the other. If you see somebody's chin strap dangling underneath, the chance that helmet actually stays on during the whole impact sequence is probably going to be diminished. A helmet's a fantastic thing, but if it isn't on your head, it's going to do nothing to protect you.
Right. Yeah, it's not enough to just have it on, but you have to have it on correctly because, like you said, it could shift if it's not on there properly.
Correct.
Yeah, and I'll add too, my kids are terrible about just dropping their helmet on the pavement, after a ride or things like that. And so even if a helmet hasn't been involved in a crash, you really have to be careful with them. You can't just throw them around, they're designed to crack. And so, yeah, keeping track of that.
We've seen people overload their kit bags, and actually break a helmet inside a kit bag.
Oh, wow.
And so that just shows you, a helmet is there for an impact, but it's not there for multiple impacts.
Right. So you mentioned earlier on about the incidence of certain types of injuries, that a lot of upper limb injuries were fairly common. So let's talk a little bit about body protection. Can you tell us the difference between sort of what's known as hard body protection and what's known as more of a soft shell body protection?
So, a number of years ago, people saw hard shell protection as proper protection and soft shell as something that was less than a hard shell. And of course, what we now understand is that even with abrasion resistance, but most certainly with impact attenuation, soft shell can be at least as good as, and sometimes a combination product is the best. So, you've got to really look at the force in your chosen sport. And how likely you are to have an injury. So if you look at, very thin hard shell protectors, they may protect against abrasion. But if you fall on a really hard rock, for example, or that hard shell protector also with say 2 or 3 straps behind it on an elbow can rotate out of the way, it may not be the best form of protection. The fact that the soft shell protection has now really advanced in terms of the materials being used, as well as how they apply to the body. We don't just look at 2 or 3 straps now. We look at a garment that is ergonomic, that fits your body properly. And if the right size is chosen, even in a proper impact, it stays in the right place. It doesn't rotate out of the way. So I think that's really important. The soft shell protectors, like the type that Leatt uses, people who do their research will know this, but those who are thinking about getting a soft shell protector, so what Leatt uses is materials that are called non-Newtonian. So they don't obey Newton's laws of physics. The harder you hit them, the harder they become. So they actually dampen the forces relative to how big the force is. When they're worn close to the body, they really are soft and very, very comfortable to use. But if they're hit at a significant impact velocity, they actually stiffen up instantly and become very good protectors. If you just look at some of Leatt's gloves that have got non-Newtonian material on the knuckles, that you can actually hit a wall with your fist without breaking your knuckles. On a regular glove, or where you had thin previous hard shell coating, you couldn't do the same. It's just a good way of understanding how effective this form of new soft shell protection actually is.
Yeah, that's interesting. I mean, it's almost as if the new soft shell with these non-Newtonian materials, I mean, it effectively is 2-in-1, right? I mean, it's soft, which is what consumers associate with, comfort and flexibility. But then in the event of a crash, it becomes that sort of hard shell protection that you need.
Correct.
And what is the idea behind that? Is it spreading that force over a wider area so that you're not getting sort of a pinpoint impact on, say, a bone or another part of the body? Is that effectively what it's doing?
Well, it takes, so if you look at a hard shell protector, it can't deform very much. So you either slide over the ground or you displace that energy, but you're not really absorbing the energy. Whereas these non-Newtonian materials, the harder you impact them, the harder they become. So the amount of force it requires to distort that protector is essentially the amount of force that's removed from the equation.
Where does the force go, though?
It goes into changing the shape of the protector. So a hard protector, you can't change its shape, whereas a deformable protector, you are changing its shape. And by displacing, if it's like taking Play-Doh, if you push your hand hard into the Play-Doh, relatively fast, that Play-Doh disperses, and you can't impact the hard surface underneath. And that displacement of the Play-Doh, or in this case, a non-Newtonian material, is where the energy is going. It's going into the displacement.
Interesting. Well, which for you is a bigger challenge? Is it designing gear that provides this effective crash protection, or is it designing protective gear that is comfortable and that people will actually wear and feel like they can still perform sort of at the same level?
So, one can wrap a rider up in cotton wool, and he will appear and probably be very nicely protected if you wrap him in enough cotton wool, but he won't be able to participate in his sport and become completely and utterly impractical. So I think that's really the trick here is producing a very protective piece of equipment is almost the easy part. The more difficult part is how to ergonomically style it to fit the rider well. And, we've moved to 3D design. So even our garments now are not designed on a normal 2D pattern as garments are traditionally made, but actually formed in using 3D modeling to ensure that they fit the rider properly. And of course, there's the other element is that, and something that I'm very proud of what Leatt's been able to do recently, and that is make a move from being a very tech kind of protective company to one that is cool. People are actually sourcing, looking for Leatt in terms of the coolness of the brand and the coolness of the apparel. Because unless you want to ride it, it's not much good in terms of protection.
Yeah. Well, I'm interested to know how or if at all the sport of enduro mountain biking has affected the design of this protective equipment. In downhill, people tend to associate sort of the biggest potential for injury. And so, helmets and pads and things like that are designed to take those bigger hits. But with enduro, the gear also has to be lightweight, and yet at the same time sort of protect against similar impacts. Is that something that you've seen as enduro has sort of grown over the years? Have the athletes asked for different products or more specific things?
Absolutely, and I think as you correctly saying, Jeff, I mean, there's no doubt that enduro is growing, and there's also no doubt that some of the enduro courses are quite gnarly. I mean, you need protection. Mm-hmm. But being able to be free and cycle uphill and as well as downhill, it is a different level of protection, and people are becoming quite discerning now. And I think that's why I think Leatt is constantly trying to produce what the rider is asking for, and we never produce protective equipment without collaborating with a very wide range of riders in different disciplines and in different regions. Mm-hmm. I mean, we've also found that We have a number of high-profile riders that we test with in certain regions, and then we send one out to a different region and get a completely different feedback. So developed a system now where we get really good feedback from a number of riders and use that to drive the innovation and ensure that we're giving riders the protection that they are already asking for.
Yeah.
And hopefully you'll see more specific, nuanced products for these different disciplines. The thing about Leatt as a company, like where we started from, which was trying to mitigate neck injuries in a very specific niche market, which was off-road motorcycling. The same applied to mountain biking, where we started off trying to protect with full face helmets and neck braces the downhill rider. And we see the company really as a mountain, whereas we start at the top and we're now being able to move down that mountain to give a broader brace of broader disciplines and more consumer product. We will always remain a refined sort of upper market, mid to upper market product in terms of price point, because of the protection and the innovation materials that we put into these products. But we most certainly as a company are moving down the mountain in terms of our offerings.
Yeah. Well, I think almost all mountain bikers tend to agree that a helmet in terms of protection is a must for riding. But beyond that, it seems like everyone has sort of a different level of protection that they want. So some people are going to wear knee pads. Some people might wear a neck brace. Why do you think people have sort of these different ideas? I mean, is it only about the type of riding that they're doing, or is there maybe a psychological component to it, or what do you think people are basing their decisions on?
I think that's a multifactorial answer. I mean, I think if your mates are riding, you're more likely to ride in the same equipment that they are, so that you sort of fit into that clique. Mm-hmm. If you're riding a certain discipline, you're more likely to adopt, once again, downhill versus cross country. You're more likely to have more protection on if you're racing downhill, for example. Mm-hmm. I think also age. We've seen a big shift to e-mountain bikes, and certainly in South Africa, it really has become very popular. And the less experienced rider and sometimes the older rider are now adopting e-bikes, which is, of course, fantastic to get out and into the mountains. But with less cycling time under their belts necessarily, heavier bicycles, and not as fit and strong as they may have been before, the amount of injuries actually goes up. So I think it also, in that instance, we've seen this whole category of e-mountain biking really demanding a different level of protection.
Interesting. Well, I have my own theory that every rider is a little bit different in terms of their common injury mode. So for me, I tend to bang my shins a lot, either on the pedal or the bike, or even in the event of a fall, it seems like I'm always hitting my shin. Whereas other people, maybe it's their hand, they've had broken hands over the years, or maybe it's a collarbone. Is that something you've seen, that it sort of varies from rider to rider, or is it more based on sort of the terrain and the sort of the external factors?
I don't have the data on to answer that question, except I can tell you my own experience. And until I went back to cleats again, I used to do my shins in all the time. And if I fall, there's 100% chance of me landing on my elbow.
Yeah.
So the most marked part of my body is on my elbows. So that's a good place to put protection, is elbow guards, and very, very rarely fall on my knees. So yes, I mean, I guess you're right, is that people have falling modes.
Yeah. Well, so for you then, when you go out for a ride, either a bike ride or a motorcycle ride, what amount of protection are you wearing? Or do you have the whole kit where you've got sort of everything protected, or do you sort of a hybrid approach?
So it depends on what I'm riding. So if I ride a motorcycle, I'm kitted up from head to foot. There are these, if you're doing long distance mountain gravel road rides, there's the chance you're going to meet a car, and there's in terms of getting to that gravel road, you definitely going to be passing cars. So I always on a motorcycle keep myself up from head to toe. I was lucky enough to do the Absa Cape Epic last year, and I'm training to do it again next year. It's an 8-day mountain bike race, 700-800 kilometer mountain bike race with significant climbing every day, and of course there you've got to ride with as little as possible. I can't even wear a hydration pack. It's a bottle on the bicycle, a helmet, and really good gloves. So crash pants are great. But you simply can't ride in elbow guards and knee guards over those distances. So that's my sport, and so I choose the best of Leatt's kit for that application. But if I'm going to ride, I'm lucky close to where I live in Stellenbosch. We've got some really fantastic riding, and we've got some nice short little downhill paths, tracks, and so there I'll wear elbow guards and knee guards, and kit myself up from head to toe. But if I'm going for a long endurance ride, then the equipment is minimal.
Yeah. Well, the Leatt brand makes protective gloves with built-in armor and even hydration packs that are designed to offer some amount of protection. So what's next for the brand?
Well, what you've seen, will have seen is that we've become a head-to-toe brand, and that is something we've been thinking about for a very long time and been executing on for the last few years. And within the last 6 months, both motorcycle-wise and bicycle-wise, now with our advent of our boots and shoes and goggles, we're now head-to-toe brand. Mm-hmm. So we'll continue to develop our brand in that way. As I mentioned earlier, we started off being a very much pinnacle of the mountain type brand, where we looked at the extremer end of the sports, and we now want to cater for more riders. And so I think you'll see more in inverted commas consumer products come from Leatt, or products where we cater for a wider range of riders.
So outside of protecting ourselves sort of on our bodies, do you think there are opportunities to make bikes themselves safer for riders?
It's not something that I've looked at specifically. I've in a previous life, I used to analyze the injury statistics for Motorsport South Africa, where we looked at track design and how by changing track design ever so slightly, you could radically reduce the number of injuries. So you have a jump and then a straight rather than a straight and then a jump. Mm-hmm. And that made, particularly in the youth riders, a big difference to injuries. So obviously track design, depending on your discipline. But in terms of bicycles, bicycles can hurt you, and specific parts of bicycles hurt you. The tips of handlebars and pedals, for example. So I'm sure we'll see development in that regard, but to be honest, it's not something that I've thought a lot about.
Yeah, interesting. Well, right, you bring up an interesting point about the tracks as well, and I think that is something that is certainly being looked at. I think along with that Enduro World Series study as well, that they looked at some of the tracks and thinking about ways to design those to make them safer. Well, Dr. Leatt, thank you so much for taking the time to talk to us and to fill us in on mountain bike protection. We really appreciate it.
Well, thanks for inviting me, Jeff. It's been great, and I hope I've given you some useful information. And if, as always, if there's any other questions you want to address in the future, please feel free to ask.
Great. Thank you. Well, you can get more information about the Leatt brand and their products at leatt.com. That's all we've got this week. We'll talk to you again next week.